Hi guys and girls, welcome back to another beautiful video on this beautiful channel on this beautiful day. How you guys and girls doing? I'm really glad that we're here. We're at this point where we're going to be talking about classes finally. And I'm a little bit scared at the same time because it's such a big topic. I would really recommend you to read a book or some type of book and read the chapter on classes. And just so you get all the details, because I won't be able to give you all the details here. I'll try to if I can. But I'll start off with a basic class introduction now. Then we'll go into maybe how to separate them more into files. Then we'll go into maybe how to initialize things better and stuff like that, optimize them, and so on and so on. So I'll try to talk about that. Now I'm sure I won't do everything correctly, because I'm by no means a professional in C++, but I do try to learn what I can. But let's just get started right now. If someone notices something, some errors, please tell me in the comment section, and I'll try to explain and correct it next time. Anyhow, so we talked about object-oriented programs. So what did we say? We said that we can represent real-world objects with objects. And a really important thing that I said in the last video was that you can think of classes as the blueprint for a building. Okay, that blueprint for a building has all the information you need to create a building, but it's not a building itself. When you follow the blueprint and create a building using all the materials you need, allocating all the space and everything, and then you finally have a big building standing perfectly after following the blueprint, that's the object. So you have the blueprint and the object. So the class is always the blueprint. Okay, so we're making a blueprint, and then we can create several objects from that blueprint. You can create several identical buildings from one blueprint, can't you? So it's the same theory here. Let's just get started. So the syntax to create a class is class or the keyword. Let's just say keyword. That's class, and then you have the name, class name. And then you have the bracket thingies. Let's just do something like this, and then let's see. Let's just do that. There you go. So this is the syntax. Let's say syntax. Keyword class name, and then you have your private and your public, and then you have constructor, destructor, public functions, okay, member functions, and then private, you have private members, private functions, public members. So we'll talk about all of these things. So this is the basic syntax, and it might seem scary, but it's not that scary. So let's just create a class. Now, instead of creating a class, my person or my class, which doesn't really tell us anything, a good way to create a class is always try to create names that really are relatable and really easy to grasp. Like, what is this object? Like, when we create a string name, we know that this object is a string because string is a really good way to explain something. It's a string of characters and so on. And so they're different objects, and the name is really important. So we want to create a class that represents a person. Okay, represents a person. So class person. We'll just call it person, and the P is capital. Usually when you create a class you don't have to, but a good practice is to keep the first letter capital in the class name. And then we need our private and the public parts. Now you're gonna be like, what the hell is the private and the public and all that stuff? And I'll explain it. Let me just start off by saying the private section of the class is things that you cannot access outside of the class itself. So if I have an integer a in here in the private section, only within the class and its functions, its member functions that are that are written in here, that are defined in here, and are part of the person class, this blueprint, only in here I can access this because it's private. I can't say, if I create a person p1 like this, and I say p1.a, I can't access that. But if I have that variable in public, that means that p1.a was accessible. See how it showed up? Okay. And it might be a confusing thing to grasp in the beginning, but all that is that I want to protect this variable. I want to protect this. This is part of my person class, and I don't want anyone to mistakenly change this and by mistake alter the data in here. It should be a little tougher to alter data in classes. So usually we create all our member variables in here, and some private functions, and then we create getters and setters. Now this is structors and destructors. I'm just creating some comments here. Functions. So what they're called are accessors and modifiers, and all those functions are the accessors send these private variables out to the rest of the program, so you can access them and get their data, and modifiers get some data from the outside into the class to these variables and change them. And all of this will be clear as we go along. But anyway, let's get started with the class. So we created a class person. Now it's up to you as a programmer to think, what is a good thing to have in a person? Now what would a person have? Well, a good place to start is a std string name, right? Every person has a name. Every person has some type of age. Maybe a person is let's see how we can define that. Maybe you can have a bool female. So if it's true or false, I don't know what you could have. You can have an integer as well, which could check if it's a female or not a female, I guess, for sex. And then you have it sounds so wrong, to define the sex of the person. So there you go. And then you have, what else does a person have? A std, yeah, it could have an std or an std string address. I hope that's how you spell address, I'm not sure. And then it's funny how I kind of work up my English while doing these tutorials as well. And then maybe std string profession, and we can have a bool for std as well, just because we were talking about that. So if you have an std or not, could be good to know in a person, right? So there you go. Now boom, so there you go. So we can have functions as well. Now functions could do different things. We'll get to that in a bit. So in our private section for the person, we have the person's name, age, female address, profession. So if I create a person in main here, if I use this class, this template, to create a person, what the computer will do, it will go through the whole person template class. It's not a template class, actually, it's just a class, but it will go through this quote-unquote template blueprint of a person, and it will see, okay, a person needs all these things, so I'm going to allocate all this memory into this object person p1 or whatever you want to call it, and all of these things will be in the memory kind of ordered and in this class structure. So whenever you access p1, you can access its things. So let me create a person me, okay, and then see how I can't access. If I press a dot here, I can't access name or anything. That's because they're in the private. They're protected in here. They're very protected. There is actually one more that is called protected, like this, and you can use that as well, but that's not for this. That's for inheritance, which we'll come to a little later. But for now, just get associated with private and public. Anyway, so they're private, we can't access them, so there's no real point in our class right now, except for storing empty data. So the next thing we're gonna need is, like you see here, we created a person, but it's all empty data in here. How do we say that a person should have the name, maybe my name here, and I want the person's age to be 28, and I want the address to be somewhere 24, blah blah blah, something something, some address, and I'll say false here, because I'm not a female, to the best of my knowledge. And then the address and profession, YouTuber / mentor at school / professional person. I think that's a profession. And then you have STD, to the best of my knowledge, no. So there you go. I have a bunch of things here that I want to do. So this is the person I want to create. I'm creating a person, me, the variable name, with all this data in it. So you can think of it as a complex array of different types. So it's an array with all these things in it, and we can access all of these with this handler, basically. It's a handle to this person class, this person object here. So now we have a bunch of things. Now I want to be able to do something like this. How the hell do I do that? Well, that's what a constructor and a destructor is for. Now what the hell is a constructor and a destructor? Well, a constructor is a function. It's just like a regular function, but the computer calls it as soon as it sees that a object of this class is being created. So it will only be called once when this object is created. You can't call it afterwards. It will never be called otherwise. It's only called here when I'm creating something new. I'm actually creating this person object for the first time here. So it will know that, and it will call the constructor for it. Now, because I don't have any specialized constructor, I haven't created anything myself, it will call a default constructor, which C++ created for me, and it isn't shown here, but we can override it if we want. But it's not shown here, and when we create our own, it will be overridden. But there is no constructor that looks like this, no function that looks like this with these input parameters. And a destructor, sorry about this, a destructor is something that's called as soon as the computer notices that this object is being deleted. So either if you say delete to this, if you have allocated it dynamically with the new keyword, or if you're at the end of a scope. I hope you watched the scope tutorial, but any function, any variable that gets the end of the scope is removed by the computer. So as soon as the program ends, in our case, me will be removed, and then the destructor will be called. So I'm gonna show you all of that stuff right now. So let's start off with the constructor. Let's create a default constructor. So this is the default constructor, and the way you create them is you give it the person, you give it the class name, exactly the same name as this. So person like this. Give it 2 empty parentheses like this, and a body. So it looks like any other function, doesn't it? Almost, except it doesn't have a return. It doesn't have anything like that. So it's just a person constructor. Now let me just go ahead and do a std cout. I am the default constructor, and a new line. And then we're just gonna copy paste this, and we're gonna create it down here, because you can create as many constructors as you want as long as they're different from one another. You can't have 2 default constructors, it's gonna complain, and they should be all different from each other. So how is my structure here? Well, just like in a function parameter list, we're gonna put these things in here. This is how I want it to look. You can have yours as in any order. You can do whatever you want. So in a default constructor, a good thing to do is to initialize all of your member variables, because it doesn't really do that on its own. The string, age, this female, all of these things don't have any default values, so I want to put some default values to them. So a good way in classes to access your things, you can write name like this, name equals none, like that. You can say age equals 0, or I'll say -1 because that's a default value. Female equals false. I guess address equals none. Profession equals none. And std equals false. I can't believe I have that in my thing. So none in quotation marks, of course, because I'm dumb. There you go. And yeah, so there you go. There you have a bunch of things. Now these are all default values. Now the reason I wrote this before is it's a little confusing, and it takes getting used to, but a good practice is whenever you're calling you mean to call all of these, any one of these member variables that you have in the class, within your class functions and stuff, always write this. Okay, it's a good thing to do because it specifies to the computer, okay, this dude or grill is really trying to access what is part of the class. It's because if I create something here, std string name, lol, whatever, it doesn't matter. I have a name local variable here, and I have a name class member variable here. They have the same name. The computer's like, what the hell's going on? Okay, I'm gonna pick the one that's closest. If you don't write this, I'm gonna pick the one that's closest to me in my scope, which is the local variable. Now this won't do us any good if we set name to none, because we want to set the actual name to none, the person's name. This local variable has nothing to do with anything. It's just here, occupying space, has the same name. So you want to make sure that in this case, if I wrote this, the computer would know, okay, I'm not going to be lazy, I'm not going to take the closest one to me. Heck that, I'm going to go up and I'm going to take my real variable, class variable name, which is further out, but I'll go grab that and change it. So this is really good, so you don't mistakenly have a local variable with the same name and you're kind of working with that. So you don't want to do that. And that will happen. I'll show you in a bit that that does happen. So I just put this in front of everything I mean when I mean to access my actual variables here, member variables. So there you go. So I set them to some random, not random, but default values. So we know that if the name is none, we know that we use the default constructor and we don't have any valid data in there. But if we want to create a constructor like this, we have to go down here, create a new one, and say std string name, and then int age bool female. Notice that I'm using the exact same names as these. You do not have to do that. You can name these whatever you want, string something, int something, as long as they have the same type, because that's what I want to get in. I want to get all this data in. But I'm using the same name for the variables just to prove a point to you guys and girls. Okay, so the computer can be confused. Which one should I use? Then we're going to use this thingy, the pointer. This is actually a pointer within a class that you have access to, which is a pointer to itself. This points to itself. So yeah, that's the best way I can explain it, and you'll get used to it with time. So bool female, what order did I have here? String, integer, boolean, string, string, boolean. Okay, so std string, I think it was the address, std string profession, and then boolean std, of course. So now you see I created a beautiful constructor that looks exactly like the one that I do want right here, and it should be fine. Now I'm just gonna do this. Oh, you don't need these actually. Doesn't matter. Okay, so there you go. Now the important thing here is, what if I say name equals name? Can you guess what the hell's happening here? Now this Visual Studio is nice. It's telling me that it's grayed out. Means I'm putting this local parameter variable to itself. I'm not actually putting this local parameter that I'm getting into the actual name variable because I didn't use this. But if I use this name equals name, then I differentiate those two. So this name, the class's name, the person's name, is equal to the name coming in from the constructor. So that's why this is important. So then I'm gonna just use this age equals age, this female equals female, this address equals address. Don't forget the arrows, because when you work with pointers, you need to use arrows to access their members. If they're not, you use pointers or you use dots. So I'll explain that as we go along in the tutorials. You'll understand it. Don't worry about it. This profession equals profession. This std equals std. So I put all of these variables equals to all of these local parameter variables. I am the specialized constructor. So that's not an official name for it, but I call it specialized constructor because it is very specialized in the way you want to put things in. I can make another constructor without these last three and give these last three some random values here. If I want to, I can create a bunch of different types of constructors. Anything you can you can want. So now I'm going to create a destructor. And in our case, it's not really necessary because C++ kind of provides that for us, a default destructor. There's nothing dynamic in this class that we have to delete, so we don't need a destructor. But in that case, if you have like dynamic arrays and stuff you have allocated with new pointers, then it could be important to have a destructor and delete those things before your class is removed so you don't get memory leaks. And again, we'll talk about that in the future. But for now, I just want to do a printout here. Hello from the Destructor. Let me just do hello and goodbye from the Destructor. Okay? And I'm going to show you where it is called, because return 0 std and cout, because return 0 quits the program. This is where our person object is going to go away. It's going to be deleted. If I have the person within as a local variable, again, watch the scope tutorials if you don't understand this. If I have it within a if statement, it's going to go away just like a regular variable. It's going to be deleted at the end of this scope. So even out here, it's not going to exist. So you have to remember that about scopes. So hello from end of program. And then we're just going to see where everything is called. So here we're going to know the end of the program. The destructor is going to be called with a cout, and we'll see when it's called. We'll know which constructor we're using and such. And then we'll go on into the next phase. So let's just run this. Like this. I am the specialized constructor. Press any key to continue. I think what happened is when we returned it, let me see if you can do this. Let me just see if you can keep it open. No, that didn't work, obviously. There we go. I want a way to actually not have it close as I run that, because as I return 0, we end. Let me just do debug, start without debugging. Okay, here you go. So I am the specialized constructor. Press any key to continue the system pause. Hello from end of program. Hello and goodbye from the destructor. So you see that? We came down here, and at return 0, when the program was quit, we got hello and goodbye from the destructor. So you can see which one we're running and when we're running it. And if I just create another person P2, I'll call them P1 and P2 so you can see. P1 and P2 with no constructor. So you don't need these two either if it's a default constructor. So we're not inputting anything, and the computer can differentiate. So when we don't input anything, it knows to use the default one. And if we have anything else, another constructor, it will know when to use it depending on what you put in here. Here it knows to use the specialized one. So let me run it and let's see what happens. So I am the specialized constructor, I am the default constructor for P2. See that? So that's how that works. Now, I hope you can see that we're using the same class, this whole code here, all this code, to create two different people. So we don't have to, you know, it makes this whole system where you create blueprints and you can create several different types of objects from those blueprints. I hope I'm recording, yes. Okay, so you can create several objects from those blueprints. And that's what makes this so beautiful. This is an object we created ourselves, and we can use it as we wish. And if I just minimize these so you can see what's going on, before I end the video, because we're at 24 minutes, you know what? I'll end the video and I'll talk about accessors, modifiers, and functions within the class in the next one, because this is too long and you guys need a break. But thank you for sticking with me. I hope you guys and girls are doing great. Take care, keep learning, keep working hard, and I'll see you guys and girls in the next one, alright? Bye-bye.